Problem number 3 is a little bit different than the last two problems because in this problem we're not given all of the angles. So I'm going to draw this out. Remember, I'm just trying to draw an arbitrary triangle out. Okay, so let's say this side is alpha again. So here's our 30 degrees. And so the side opposite of alpha, A is going to be 1 for the length. Here's gamma, which we don't know. Here's beta, which we also don't know. And we can't get gamma or beta right now because we're only given one of the angles. So now we'll look at, we have C is equal to 4, B we also don't know. So let's try to solve. What we do have is alpha and A. So I do have part of my law of sines formula. So that would be the sine of 30 degrees over the length of A, which is 1. So now, using that, let's see if we can find, let's go for, now we can't do anything with beta or B because we don't have those. So the only thing that we can really solve here is for gamma. So I've got this sine of gamma over 4. So I want to solve for gamma. So what I'm going to do is I'm going to simplify a little bit here. The sine at 30 degrees is 1/2. Divided by 1 is still 1/2. So another way to think about this is sine. So to not confuse you, sine of 30 is equal to the sine of gamma over 4. So the sine of 30 is 1/2. You can do that on your calculator if you want. You get 0.5, and that's going to be equal to the sine of gamma over 4. Multiplying both sides by 4, I get 2 on the left side, and I get sine of gamma on the right side. Now, what we would typically do we would take the arc sine of both sides. Okay, so we'll do that here. There's going to be a problem. So gamma is equal to the arc sine of 2. If you try this on your calculator, you're going to get an error. And the reason for that is because this right here, or this right here, whichever way you look at it, says we're looking for an angle whose sine value is 2. But there's a problem with that. There is not an angle out there. If you take a look at your unit circle and you draw out your picture here, sine measures up and down, but the highest we can go is 1, and the lowest we can go is -1. So the height values are always locked between -1 and 1. So when I say the height value is the outputs, that's the range of sine, which means that there is no angle. Okay, so no such angle. Which means that this setup right here is not possible. At least there's no triangle that has an angle of 30, a side length of 1 here, and a side length here of 4. So what does this triangle really look like when I draw it out? Well, it looks something like this. It has a side length of 4. It has an angle of 30 degrees. But when I try to drop this side length of 1, it's just not long enough to ever touch this other side. So what happens here, if you look at this picture, as I unwind my pen here, as you look at this picture, this thing right here, this angle is fixed, meaning it can't move. This side length is fixed, meaning we can't change it, so is this side length. The only thing that can change are the two angle values and this base length. But it doesn't really matter how long this base length is, because look, if I change this angle up here for beta, okay, and we start looking at all the possibilities, as we try to, no matter where we stick this, no matter where I rotate this side length right here, it's never going to be long enough to touch this side. And so that's the issue, is that we created a situation where the length of this side is just not long enough to hit this other side length. Now, I can tell that by looking at this a little bit, but I can also, by just looking at the problem, but I can also tell by trying to solve, because you end up with this error situation. So be careful on problems like this.